Okie dokie. So let's go ahead and go over the solutions to this worksheet. So remember how your table of friends works. The variable, let's get a pen. The variable for mass is m, and the unit is kilogram. The speed is v, and you can remember that because of velocity, and the unit is meters per second. And then kinetic energy is simply in joules. The derivation of that joules from your equation for kinetic energy is a little bit tough, so it's totally fine if you just remember that energy is always measured in joules. All right, so that equation that we introduced is 1/2 mv squared. All right, so let's do a problem. It says, how much kinetic energy does an 8-kilogram bowling ball have if it moves at 6 meters per second? So I'm just going to grab another color so we can sort of see what we're seeing. All right, I see that kilogram, and I see that kilogram. So one of the nice little tricks you can do with the table of friends is you can really use it to figure out what to put in the box. So I see 8 kilograms, so I'm going to write an 8 in front of kilograms. And then I'm going to write an equals here, and then there's my variable. So that's what I need to write in my box. M equals 8 kilograms. Okay, I see a meter per second, and it's 6 meters per second. There's the meters per second. I'm going to write equal, and then what do I have to my left? I've got a V. So now I know that V is 6 meters per second, and I'm looking for kinetic energy. And so I can write kinetic energy is some number of joules. Don't know. If I'm thinking about it, I can just write that joules right there so that I don't forget to give it in my answer. So my formula for kinetic energy is always going to be 1/2 mv squared. And so let's write this out. 1/2 m is 8 kilograms, and v is 6 meters per second, but I can't forget that squared. Okay, so when we actually want to do this on a calculator, remember we have to do the squared first. So I'm going to bring up a calculator real quick. So I've just scooted my stuff over, so I want to know, how do I put in 1/2 times 8 times 6 squared? So there's a couple different ways of doing it. Let's try 6, and then you'll see a squared button over here to the left. Okay, 6 squared. I kind of like to start at the right and then go backwards. Times 8. And then you might say, how do I do times 1/2? Well, times 1/2 you could do times 0.5. Okay, and that's 144. Let me show you a couple other ways of doing this in your calculator. That's clear. Oops, I'm writing on it. Haha. Try that again. All right. So, you could also just do 6 squared times 8, and times 0.5 is the same thing as divided, times 8, and then the same thing as divided by 2. So that's also 144. Or you can go from the left. You can do 0.5, 0.5 times 8 times 6 squared. That's fine. If you're scared of the squared button or you can't find it, you could do 0.5 times 8 times, guess what? Squared is just 6 times 6. That also works. So find a way that works for you. If you need help, come to AT. All right. Let's keep going. So let's move this guy. A 1.2 kilogram taco strikes a wall with a velocity of 8.5 meters per second. Why would they do that to the taco? That makes me sad. How much kinetic energy does it have? All right. we see that it's a 1.2 kilogram, and we know, we can look at our table of friends, we know that that's M, it's the mass, and the V is 8.5 meters per second, and kinetic energy is question mark, right? Make sure our joules are there. So kinetic energy is 1/2 mv squared. So 1/2, and our mass is 1.2 kilograms. Our V is 8.5 meters per second, and we have to square it. So let's bring our calculator over here. Oopsie. Okay, there we go. Sorry. So let's do it. All right, you want to just go from the left? That's cool. 0.5 times 1.2. Sorry, my Apple Pencil is not being very happy here. .5 times 1.2 times 8.5 squared. Boom! 43 pen 43.35 joules. All right, there it is. All right, so this last question, there's a lot of different information. Let's see, what do we have? We have a mass. We have a speed. And then, oh my goodness, what else do we have? We have a height. So I'll remind you that PE equals mgh for potential energy. Okay, so this first one is just like the ones we just did. Kinetic energy is 1/2 mv squared. We've got M is 81 kilograms. We've got V is 44 meters per second, and the kinetic energy is question mark. So kinetic energy 1/2 81 kilograms, 44 meters per second squared. And when you put that in your calculator, sorry, I wasn't bringing up the other one, but it is 78408 joules. Awesome. Okay, this next question asks us for potential energy. So look at this. This problem gives us information for the whole problem. So it doesn't mean we didn't need the height to figure out kinetic energy. And guess what? We're not going to need the speed to figure out potential energy. So potential energy is mgh. We know the mass. We know the height. And we want to know the potential energy. We also know, oops, maybe the box should have been bigger, haha, that G on Earth is 9.8 newtons per kilogram. Okay, so my mass is 81 kilograms. The G is 9.8 newtons per kilogram, and the height is 650 meters. So when we put that in our calculator, we get 515,970 joules. My goodness, that is a lot of joules. So the last question says, what's the total mechanical energy of the skydiver? The total mechanical energy is the kinetic energy plus the potential energy. So you add those guys, and you should get 594,378 joules. So if we're actually like thinking about this, if this is our total, our potential is most of it. And the kinetic energy is a lot smaller, right? So if you're thinking about this skydiver falling. Oh my gosh, that's a lovely person. Here's the ground. They just started falling there, then maybe they're just right here, okay? And that's because you can tell how much the potential energy is compared to the total mechanical energy. All right, hope that helped.